All right, looking at our review here, we got problem number 11 is what we're starting with. Number 11 says 14x to the fourth y over 2x cubed y to the fifth. And dealing with these, we want to always try and take care of our numbers first. So here, 14 divided by 2 is going to be 7. Looking at my variables, looking here at my x terms, I have 4 x's on top and I have 3 x's on bottom. So therefore I have 1 x left on top. Next I have my y variable. With the y variable, I've got more of them on the bottom, so that means there's going to be some left chilling on the bottom. I got 1 on top, 5 on the bottom, so that leaves me with 4 on the bottom. And Bob's your uncle. Okay, next we're looking at problem number 13 here. Problem number 13. It says parentheses. Here we have 4r squared plus 3r. 4r squared plus 3r minus 1. Minus another set of parentheses here. Here we have 3r squared minus 5r. 3r squared minus 5r plus 4. Okay? So now with these, I have to always remember, hey, I have to distribute this bad boy here into each one of these. So my first part does not change. He stays the same. 4r squared plus 3r minus 1. This now becomes minus 3r squared plus 5r plus, not plus 4, that's a minus 4. Erase. Now so we get back to where we need to be. Minus 4. Now at this point we need to collect our like terms. So I'm going to start with my r squares. Notice when I do this, I always circle the sign in front of it. So 4 minus 3 gives me just the plain old r squared. Next, I have a 3r and a 5r. 3r and 5r gives me plus 8r. And then I have a negative 1 and a negative 4, which gives me a minus 5. And once again,
Bob's your
uncle. Looking now at number 15. Number 15 here, I have parentheses. I'm going to be multiplying this time. M plus P times M squared minus 2MP plus P squared. So to multiply these, lots of different ways we could go about multiplying these. I'm going to employ the box method of multiplying, just because whenever you're multiplying a binomial times a trinomial, it's easier to keep things in track of where they're going. You don't get confused with having to do our repeated distribution. So I like the box method for this particular problem. The box method looks like this. You first draw a box. Okay? Box method. On top of my box here, I'm going to divide it into 3 sections. I'm going to put m squared minus 2mp, and I'm going to put p squared. Then I'm going to divide my box this way, down the middle. And I'm going to put m here and p here. And now basically all I'm doing is filling in area models. Okay? So I'm going to do m times m squared, which gives me m to the 3rd power. M times 2mp, that's a negative 2m squared p. M times p squared is, p squared. Filling in my next box down here, I have p times m squared, that's going to be m squared p.
Isn't that like from squares in biology?
It's real similar to Punnett squares in biology. Just basically going to fill it in the boxes. So right over here. Okay. So now I've got to take and multiply p times my negative 2mp. So it's going to be a negative 2mp squared. And then p times p squared is p to the third power. At this point, we go and collect all of our little like terms. Starting in my upper left-hand corner, I have m to the third power. Notice these here diagonally are the same. So I have a negative 2 and a positive 1 gives me a negative m squared p. Next, oh look, these two here diagonally are like terms again. So that gives me a negative m p squared. And the last thing I have chilling at the end, p to the third power. And at this point right here, we can stick a fork in him because he is done. All right, moving along here, we're going to move down to number 17 now. Problem number 17 says, we got a lot of stuff in number 17. We got 12x to the 4th, y something or another, y to the 5th plus 8, 8x cubed, y to the 7th, minus 16x squared, minus 16x squared, y to the 6th, and it's all over 4xy to the 5th. 4xy to the 5th. Anytime you're dividing a polynomial by a monomial, we just go through and separate them out as individual fractions and reduce each one up. So this first one becomes 12x to the 4th, y to the 5th, over 4x, y to the 5th, plus 8x cubed, y to the 7th, over 4x, y to the 5th, minus 16x squared, y to the 6th, over 4x, y to the 5th. So now we got to go through and simplify each one of these individual fractions.
Right.
So looking at this right here, I go through and say, hey, I can reduce this thing here. This gives me a 3, and that gives me a 1. With my x's, this one on top is larger, so this one can cancel this out here and leaves x cubed. And then my y's are completely eliminated. So my first term is 3x cubed. Moving on to my second term, everything is positive, so I'm going to put a plus sign here. I can look at this and say, hey, 4 goes into 8, leaves a 2 here and a 1 here. My x's, I can look at those and go, oh, x here leaves x squared on top. Here, these cancel out. Cancel that out here, leaving a y to the second power. So my second term is 2x squared, y squared. Moving on to our last term, our third term, we have a minus sign, so that's a minus. I look at my numbers, the numbers first. 4 goes in here, leaving a 4 and a 1. Next, I look at my x's. This goes here and here, leaving an x. Then my y's, this goes here and here, leaving a y. Because we like you. Hello, USC. And we have 4xy. And at this point, we say, stick a fork in him, he is done. Okay? All right, our next one we're looking at here, number 19. Number 19 says that we have 8 to the 4th plus 5a cubed. So 8 to the 4th plus 5a cubed. And then we have plus 2a squared plus 2a squared minus 6a. Plus 4 times a plus 2 to the power of negative 1. Oh, the little kicker right here is this little devil right here. That negative 1 means, hey, this is really the same thing as not saying this. We can rewrite this as 1 over a plus 2. And if it's like that, that means that we are going to be dividing. And since we are dividing, and our leading coefficient here is 1. For this particular one here, I can use my synthetic division. So my synthetic division looks like so. Put me a little backwards box right here, and go and put me a little line over here. Okay? Make my page a little higher so we can all see what's going on. I now take and put this, the opposite of it, over here. So I put in a negative 2 here. I now list out all of my coefficients here. I want to first check my exponents. I have 4 here, so it goes 4, 3, 2, 1, 0. Perfect. We don't have to put any placeholders. So I'm going to go through and list these out. I have 1, 5, 2, negative 6, and 4. And underneath this one here, I put me a little backwards box, because that's where my remainder goes if I happen to have one. I now take and move along, and it's a matter of just multiplying and adding, multiplying and adding. 1 plus 0 is 1. Then I multiply, going back this way. Negative 2 times 1 is negative 2. Then I add. 5 plus negative 2 is 3. And then I multiply. Negative 2 times 3 is negative 6. And then I add. 2 plus negative 6 is negative 4. And then I multiply. Negative 2 times negative 4 is a positive 8. And then I add. Negative 6 plus 8 is 2. And then I multiply. Negative 2 times a positive 2 is a negative 4. And then I add. No remainder. So now I need to go write my final answer. My final answer starts off with the exact same thing I have here, just one less exponent. And then I count down to 0, just like I do when I check it. So my first term is going to be a to the third power plus 3a squared minus 4a plus 2. Winner, winner, chicken dinner. We have a winner. Number 21, they give us a problem that's actually rooted in some geometry here. So we have a nice, pretty prism. Looks like so. And they tell us that the height of this prism is 3x plus 2. And then they tell us that the volume of our prism is 3x cubed. Something over here. Plus 11x squared. Minus 114. X minus 80. Okay? So there's our problem. We need to go figure out what is the area of the base. Now the area of the base is actually this area right here. That's what we're looking for. What's the area of this thing here? So we can go through and do division, because we know from our geometry and from our formulas that our volume is equal to the area of the base times the height. I have my height, I have my volume, so it's a matter of dividing. With this, you have to do some long division. So my long division looks like so. I put my 3x plus 2 here. I put my 3x cubed plus 11x squared minus 114x minus 80 right there. And now all I care about is this leading term here. I look at my leading term of 3x and say, what can I multiply 3x by to turn it into a 3x cubed? Well, he needs an x squared. Yeah, he needs an x squared. So I'm going to put an x squared right here. So now I multiply x squared times each one of my terms, not just the first one, but both of them. So x squared times 3x is a 3x cubed. X squared times a 2 is a plus 2x squared. But remember, in long division, you always subtract at that level. When I do so to subtract, these two pieces are eliminated, which that was my goal. Make sure they go away. I now have to remember that this minus sign and this plus sign makes that a minus. So 11 minus 2 is 9, and I have an x squared, minus 14x minus 80. Then I start all over again and say, hey, what can I multiply 3x by you turn it into a 9x squared. Well, 3 times 3 makes 9, so I need a 3. And then x times, oh, so I need a 3x. So we're going to multiply by a positive 3x. So 3x times 3x gives me 9x squared. 3x times 2 gives me a plus 6x. So remember, in long division, at this level, you are always subtracting. And in subtracting, these two pieces are eliminated. I now have to remember that this minus and that plus makes that a minus 6. So it gives me a negative 120x minus 80. Let me start all over. I say, what can I multiply 3 by that turns into a negative 120? Oh, that would be a negative 4e. Negative 4e times 3 is a negative 120 with my x chilling there, and a negative 40 times 2 is a negative 80. So remember, in long division, you are always subtracting at that level. And in doing so, these first two have been eliminated, which was my goal. Then I've got to remember, hey, a negative, a minus and a minus makes that a plus. A negative 80 and a positive 80 gives me a remainder of 0. Therefore, the area of the base is right there. All right, in this part of the sections, we're going to be looking at what can we factor and not factor. Here, from number 35. Number 35. We are given x cubed plus 6y cubed. Well, I don't have a GCF, so I can't do anything with that. Let's see. This one right here is a nice, pretty perfect cube. That's a pretty perfect cube, but this bad boy is not a perfect cube. So I don't have any other rules that I can do with this, so I'm going to stop and write prime. This one cannot be factored. It does not fit any of our rules or any of our special cases, so there's nothing we can do to it. No GCF, nothing at all can happen to it. So therefore, it's not factored. Let's move on and look at number 37. See if we can actually do something with number 37. So number 37 is telling me 6ay, 6ay plus 4by minus 2cy plus 3az, it just keeps on giving and giving, plus 2bz minus, minus, I forgot what it was, that old timer's getting me again, cz. Okay, so we want to go through and see, what can I do with this? If I look at these things right here and say, look at all three of these, they all have a y and a 2 in common. So let's pull a 2y out of these three things and see what happens. So if I pull a 2y out, I'm left with 3a plus 2b minus c. That's cool. Let's go over here and see what happens with this one. If I look at these three pieces, do they all have something in common? Why, yes, they do. I can take a z out of all those. And we're going to take a positive z. So we take a plus z out, which leaves me with 3a plus 2b minus c. Oh, look at this. Isn't this nice? This one and this one are now the same. So, 6, 4, and 2 can all be divided by 2. Part of our GCF, our greatest common factor. Now my greatest common factor is going to be the items that are in parentheses. So therefore, I'm going to pull my items in parentheses out. So I have 3a plus 2b minus c. And if I pull those things out, that means this one is pulled out and this one is pulled out. What's left over? How about 2y plus z? And at this point, your uncle.
Okay.
Number 39. There's a little bit of room here. Number 39 says that we have 8x to the 4th. 8x to the 4th minus 10x squared plus 3 is equal to 0. Oh, x to the 4th. I don't like looking at x to the 4th and x squared and stuff. So I'm going to come over here to the side and say, hey, let x squared equal 2. So when I go and plug this back in over here, I now have an equation that looks like this. 8 u squared minus 10u plus 3 is equal to 0. Now I'm used to looking at problems like this, so I can go and factor. I'm going to take and use our illustrious rainbow method, even though it's kind of crazy. We're going to do it anyway. 8 times 3 gives me 24, so I now have u squared minus 10u plus 24 is equal to 0. I do this because it allows me just to drop in here. Hope that didn't steal anybody's wave. So I go right here, put u, and I put a minus and a minus because this is a plus and that's a minus, and say, what can I multiply to get 24 but add to get 10? How about 4 and 6? 4 here, 6 here. But now since I took my 8 to the right, I got to go bring him back to the front. So that means I got to divide both of these things by 8. Okay? Now when I do that, I have to reduce the fractions first. This one reduces to 1/2. This one over here reduces to 3 over 4. Now in doing so, my denominator always goes in front of my variable. So my factored form is going to look like 2u minus 1 times 4u minus 3, and that's equal to 0. And now that I have that, I set each factor equal to 0. So I say 2u minus 1 equals 0, and then I come over here and say 4u minus 3 equals 0. Working on the 1 on the left. First thing I do is add 1. So that's going to give me 2u is equal to 1. Divide both sides by 2. So this now gives me u equals 1/2. Working on the 1 on the right. Start off. Plus 3 plus 3. 4u is equal to 3. Divide both sides by 4. U is equal to 3 over 4. But wait a minute. We don't have u. U is really x squared. So I can rewrite these things now as x squared is equal to 1/2. X squared is equal to 3 over 4. So I now have to take the square root of both sides. Square root of x squared, square root of 1/2. So this one over here tells me that x is equal to 1 over square root of 2, and this is a plus or a minus always. Oh, I can't leave a radical in the denominator. I've got to fix that. We multiply by a magic 1 of square root of 2 over square root of 2. And in doing so, we find out finally that x equals plus or minus square root of 2 over 2. Whew, there goes 2 answers. Now I gotta go do the same thing over here.
Right.
Man,
Let's do it.
these things got a lot of stuff going on, though.
Let's do it.
We can do it. We can do it. Here we go. X squared. Take the square root of this one over here. 3 over 4. all in this amount here, nice of them. This one says x is going to be equal to plus or minus this plus or minus the square root of 3 over, oh good, I don't have to do anything to that one. He is done. So I have 4 solutions to this problem. I have 4 solutions because my highest exponent was 4. Number 41, using synthetic substitution here. Number 41. Oh, that's a fat marker there. Let's change that. Number 41, we've got f of x is equal to x squared minus 3. And they said, hey, go find f of negative 2 and f of 4. So using synthetic substitution, that means we're going to go through and do our synthetic division, like so. Pay attention here, this is x squared, so I still need an x to the first power term. So I'm going to go through here and put my negative 2 here. I put 1, 0, negative 3. Right here is where my solution is going to end up. Using my synthetic division, I bring my 1 down. I multiply, that's negative 2. I add, that's negative 2. I multiply, that's 4. And this is going to be 1. So therefore, f of negative 2 equals 1. Synthetic substitution. You do your synthetic division using these numbers to substitute, and that will give you your solution in the form of a remainder. We do number 4. If we do 4, so 4 here, 1, 0, negative 3. So that's going to be 1, 4, 4, 16, 13. F of 4 is 13. Looking at problem number 43, we're still dealing with our synthetic substitution. Problem number 43 says f of x is equal to something. It says x cubed plus 4x squared. So x cubed plus 4x squared. See, then we got a minus 3x plus 2, minus 3x plus 2. And again, we have to find f of negative 2 and f of 4. So we're going to go through and do our synthetic division. Doing my synthetic division, I set up a little backwards box right here, draw me a line across over here, and I say, hey, I'm going to put my negative 2 here. I check my exponents. I have 3, 2, 1, 0, so I do not have to place any placeholders for this particular problem. So here I go and put my coefficients. In this case, it's 1, 4, negative 3, and 2, and underneath the 2, that's where my solution will end up. Now to do my synthetic division, I bring down my 1. I multiply negative 2 times 1 is a negative 2. I now add, that gives me 2. I multiply, gives me a negative 4. I add, gives me a negative 7. I multiply, gives me a 14. And 2 plus 14 is 16. 16 is the answer, so f of negative 2 is 16. Doing our f of negative 4. We do the same thing. So my little synthetic division, putting the 4 here, going back over here and putting 1, 4, negative 3, and 2. Underneath the 2, there's where my solution will end up. So I go over here, bring down my 1, and 4 times 1 is 4. 4 plus 4 is 8. 8 times 4 is 32. And 32 and negative 3 gives me 29. 29 times 4 is 416. And then we add those things together, gives me 118. So f of 4 is equal to 118. Looking here at our next problems, we're going to be looking at how to factor a polynomial giving one of its factors. So we can have it factored completely. So looking here, this is problem number 45, and it helps if I actually get my pen to work with. 45, there we go, 45. And my original problem says that it is 3x cubed plus 20. 3x cubed plus 20x squared plus 23x minus 10, And then they gave me a factor that is x plus 5. So we need to continue factoring the rest of this problem. So to do this, the first thing I'm going to do is do my synthetic division. So I'm going to go set my little house up. Little house on the prairie. Alright, we're going to go plug this thing in here at -5. Check my exponents here. I have 3, 2, 1, 0. So my exponents are good. We do not need placeholders. I now place in here 3, 20, 23, and a -10. My remainder should come out to be 0 since I was told x plus 5 is a factor. So I go through and doing my synthetic division. I bring my 3 straight down because 3 plus 0 is 3. -5 times 3 is a -15. 20 plus -15 is 5. -5 times 5 is a -25. 23 and a -25 is a -2. -5 times a -2 is a +10. My remainder is 0. So I now change this equation here to 3x squared plus 5x minus 2. I need to factor this. Lots of different ways to go about factoring. We're going to use the rainbow method of factoring, where I'm going to take and multiply 3 times my -2 and change my equation now to x squared plus 5x minus 6. Now I can say, hey, what can I multiply to get 6 but subtract to get 5? How about 6 and 1? X plus 6, x minus 1. Well, I moved my 3 to the right by multiplying, so I have to undo that and move it back this direction. So I have to divide now both of these things by 3. 6 divided by 3 leaves 2, so I have x plus 2. This one right here, the 3 moves in front of my x, so I now have 3x minus 1. And there's my two new factors. So the complete factored form for number 45 would be x plus 5 times x plus 2 times 3x minus 1. All right, looking at number 47 here. Number 47 is the same thing as it was with number 45. We're going to be taking and factoring completely. We had x cubed plus 2x squared, so I have, just plain old x cubed. Oh my goodness. All right, let's try again. X cubed plus 2x squared something. Oh, there it is. Minus 23x. Minus 60, and then my factor that they already gave me was x minus 5. Oh, x minus 5 this time. So we're going to do our synthetic division. Set a little stuff up here for my synthetic division. I go through and check my exponents. I have 3, 2, 1, 0. Perfect. We don't have to put any placeholders. I put a positive 5 right here. So we always put the opposite of what this one is. And then I put my coefficients lined out here. I have a 1, a 2, negative 23, negative 60. Underneath this negative 60 is where my remainder goes, and it should be 0 at this point. I now take and do my synthetic division. I take and bring down my 1, because 1 plus 0 is 1. I multiply 5 times 1 is 5. I add 2 plus 5 is 7. I multiply 5 times 7 is 35. Negative 23 and a 35 gives me a positive 12. And then I multiply 5 times 12 is 60. Negative 60 and positive 60 gives me a remainder of 0, which is what I should have got. So my new equation now is x squared plus 7x plus 12. I now need a factor this part here. Luckily, my leading coefficient is 1. Since my leading coefficient is 1, I can automatically jump in, putting an x here and an x here. And I can say, hey, 3 plus 4 gives me 7, and 3 times 4 gives me 12. So there's my other two factors. So my completed factored form for number 47 is x minus 5, x plus 3, x plus 4. This next section here, we're going to be looking at how to find our possible zeros. Possible real zeros, positive ones, negative ones, and any imaginary zeros that we have. This one is actually problem number 49. 49, they start off by telling us that f of x is equal to f of x is equal to negative x to the 4th. Then we have minus 2x cubed minus 2x cubed minus 12x squared minus x minus 23 minus x minus 23. Here we're going to use our change of sign rule. Our change of sign says, hey, let's see how many times my signs change within the problem. Well, going from here to here, it did not change. Going from here to here, no, still negative, did not change. Here to here, no, still did not change. And then here to here, oh, it still did not change. So I have no changes in this one, so therefore that tells me that I have no positive real zeros. You know, I know how many zeros I'm supposed to have by my first exponent. My largest exponent tells me that there should be 4 zeros. I like to set up a nice pretty little table for this. So it might be a little pretty table here. Across over here, down here. Oh, isn't that pretty? I have my positives, I have my negatives, I have my imaginaries, and then I have the total. Well, this one right here, my total always has to come out to be 4. Well, these are all going to be 0, always. Okay? So it doesn't matter, my positive ones, I have to have zeros. Well, let's go find my negative ones. Well, in order to find out how many negative ones, I'm going to go and substitute in a negative x into my equation, simplify it a little bit, and see how many sign changes I get this time. So I'm going to put in here my negative x to the 4th minus 2 negative x to the 3rd minus 12 negative x squared minus negative x minus 23. So we need to simplify this a little bit. So in simplifying this, negative with the exponent of 4, anytime you have even exponents and we raise it to a negative to that even exponent makes it positive, so this one stays negative x to the 4th. Here I have negative 2, and this negative is going to stay negative because it's an odd exponent, so 2 negatives make that a plus 2 x cubed. Here I have a negative 12, and this negative is going to become positive because of the square, so that still stays a negative 12. So I have a negative 12x squared. Here, straightforward, 2 negatives make positive, so it's a plus x. And then my minus 23, he's not going to do anything but just chill at the end. Now I need to see how many times did my signs change. Change. Oh, yes, it changed. Going from here to here. Oh, look, we changed again. Okay. Going from here to here. Oh, look, we changed again. Oh, look, over here, we changed again. So we had 4 sign changes. So therefore, for my negative ones, I have the possibilities of 4, which means there would be 0 imaginary. We already know my positives are always going to be 0. But this one could be 2, which means this one could be 2, which then gives me 4. This one's always 0. Well, this one could be 0, because we always can count down by 2s. We can count down all the way to 0 by 2s, and that's what will happen, which means there will be 4 of these, and that gives me 4. So there are my possible solutions. These are my possible solutions. We do not have to go find our solutions here, but these are the things that are possible to happen. This next problem, we're going to be doing the same thing. This is actually problem number 51. 51 tells us that we have f of x is equal to f of x equals negative 2x to the fifth plus 4x to the fourth plus x squared minus 3. So here, first I want to go through and figure out what are my changes. It's my sign, straightforward, the way it is. Yes, it changed. No, it did not change. Yes, it changed. Let's go make our table so we can keep track of what we got going on. So I make my table. So I have my positive, I have my negative, I have my imaginary, and I have my control. In this case, my total has to equal 5 every single time, because 5 is my highest exponent. Here I have 2. So I have 2 positive possibilities. Let's go and check for our negative possibilities. So my negative ones, I'm going to plug in a negative x into the problem. So I have negative 2, and that's negative x to the 5th power, plus 4 times negative x to the 4th power, plus negative x to the 2nd power, minus 3. So I've got to simplify each of these. This one right here, this becomes a negative, and negative makes that positive. So this now becomes 2x to the 5th. This one right here, it becomes positive because of that even numbered exponent. So that's a plus 4x to the 4th, plus 4x to the 4th. This one right here becomes positive because of our even numbered exponent. So it stays plus x squared. And my minus 3 is just chilling at the end. So now checking, what are my sign changes? That's a no, no, 1. So therefore I know that I have, no matter what, I have to have one negative solution. But looking at this, I have 2 positives, 1 negative, so that means I have 2 imaginary. I can count this down by 2s though and say I have 0 of these, 1 of these, because I cannot change my negative choices. And then I would have 4 imaginary, because they have to total 5 as well. And there are all my possible solutions for f of x equals negative 2x to the 5th plus 4x to the 4th plus x squared minus 3. Rolling here. With these, we actually have to go find our solutions here. This is actually problem number 53 here. 53. And it says f of x is equal to x cubed. No, that's not it, is it? Yes, that's it. X cubed plus 4x squared. X cubed plus 4x squared plus 3x minus 2. Plus 3x minus 2. So the first thing I want to do is go and figure out what are my possible solutions. So to find my possible solutions, I'm going to think about my P and my Q. P in this case is a 2 and my q is a 1, so I look at all the combinations of p over q. So for this particular one, I've got the factors of 2 are 1, so I've got 1 over 1, and then I have a negative 1 over 1. And then I have a positive 2 over 1 and a negative 2 over 1. So there are my possible solutions. These things will actually simplify to 1, negative 1, 2, and negative 2. So I can use these to start my guessing and checking with my synthetic division. So setting up my synthetic division here, I'm going to start with 1. And I'm going to come over here and put 1, 4, 3, negative 2. In order for this to be a solution to it, it needs to have a remainder of 0. If we do not have a remainder of 0, we'll cross it off and move to our next guess. Here, I bring down my 1, and 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 5 plus 3 is 8. 8 times 1 is 8, and I do not think that gives me a remainder of 0. So I'm going to take and put a big old fat X across that one and move to my next guess. My next guess, I'm going to use negative 1. So I come over here and I put negative 1. And I put 1, 4, 3, and negative 2. Again, 1, 4, 3, negative 2. And again, we need a remainder of 0. So I bring these things down doing my synthetic division. I have 1. That'll give me negative 1. That gives me 3. That gives me negative 3. That gives me 0, which gives me 0. And again, that does not give a remainder of 0. Cross it off. My next guess is positive 2. Let's try the positive 2. Let's see what happens with it. Positive 2. With positive 2, we're going to put 1, 4, 3, negative 2. Do my synthetic division again. I have 1, this is 2, this is 6, this is 12, this is 15, that's 30, and that definitely will not give me a 0. Mark it off. I only have one choice left, otherwise we're going to get some crazy stuff going on. So let's see, hopefully this one works, negative 2. So I have 1, 4, 3, negative 2. Doing my synthetic division, I bring down my 1. This is a negative 2. This is a 2, so that's a negative 4. This is a negative 1, so that's a positive 2. Winner, winner, chicken dinner. We have now found one solution. One of our solutions is x equals negative 2. And now I'm going to take my equation that I just created down here. My x squared plus 2x minus 1 is equal to 0 and solve this one. Looking at this one, can I factor? Well, in order to factor it, I'm going to say, hey, what could I multiply to get 1 and subtract to get 2? I don't believe there is anything. Since there's not anything, I will have to go and employ the lovely formula of the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, our quadratic formula. Using our quadratic formula, I plug in my information that I have. In this case right here, this one will be x is equal to the opposite of 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 1 all over 2 times 1. So when we go to simplify this, this now becomes x is equal to negative 2 plus or minus the square root of 8 all over 2. I can simplify the square root of a, so this becomes x is equal to -2 plus or minus 2 on the square root of 2 over 2. Looking at this, go, hey, look, my Mickey Mouse ears. They all have a 2 in common. Since they have a 2 in common, I can reduce this, which my final answer here becomes x equals -1 plus or minus the square root of 2. And there are my other two solutions. Good luck.